Hello friends, this is Durga again from ITversity. As part of this video, I'll be covering uh, uh, joining disparate datasets together using Spark in Python, which is Pyspark. Um, and Let's go ahead and start talking about. So, if you are familiar with SQL, you might know what is join is. In a normalized database, there can be related tables, typically with parent and foreign key relationship. And if you want to get uh, uh, related data and run some queries against those tables based upon the relations, we typically use joins. There are different types of joins: inner join, outer join, left outer join, right outer join, and full outer join. There are different things. In this video, I will try to cover uh, typical inner join predominantly. And once you understand what is join is, and once you understand how you can run it, you can easily run a left outer or right outer join or any other joins which are supported uh, by Spark. So let's go to Spark documentation. And as I have mentioned earlier, you have to go to Spark programming guide to understand the syntax in Python or Scala. And here, if you want to go to Python, you just click on Python on any of the topic, and the entire material will be refreshed in Python context. And then you can go to the transformations and actions. Those are the ones which we typically use to perform operations on RDDs, which stands for resilient distributed datasets. And if you go to here, it actually show you that there is one function called join on top of RDDs. And not only join, if you read the entire text here, it also supports left outer join, right outer join, full outer join, etc. So now we will see how we can do it. So before actually developing, let us define the problem statement. The problem statement in this case is, we have a orders table and we have order items table. So if you are following this curriculum from the beginning, we have imported all the tables earlier with the create hive table option in scope, which have created hive tables in our VM. So let me launch another terminal, and if you go to hive, and run show tables in default database, you can see that there is a table called orders and order items. So you can go to a Hive, or you can even go to MySQL if they provide access to MySQL in the certification, or if they already say that there are tables in Hive, you can either go to MySQL or Hive to get the metadata of your data, or they might provide the metadata directly. So using one of the approaches, you can actually get the metadata. In this case, I am using Hive, but I think as part of the certification, they will give you the table structures directly, so you can base upon them. So I am running describe command, describe orders. You have order ID, order date, order customer ID, and order status. And if you look at describe order items, there is order item ID, order item order ID, order item product ID, quantity, subtotal, product price. So I have explained in the context of scope about the data model. If you recollect, orders is the parent table of order items, and order ID is the primary key in orders. Similarly, order item ID is the primary key for order items, and order item order ID is nothing but order ID from orders, and it's a child table. It's a 1 to n relationship between orders and order items, which means that for a given order there can be a number of order items in them. And if you want to join these two data sets, you have to use order ID from orders and order item order ID from order items. Okay, And our data set, I'm launching another console. So as part of the scoop import, we also copied data to this location, user cloudera scoop underscore import. In certification, if they already have the data in HDFS, they might give you the details. Otherwise, there might be a end-to-end exercise wherein you have to copy the data first into HDFS, either by using Scoop or Flume. Those two are the things which are covered as part of the certification, or they might have give the comma separated or some delimited data, and they might ask you to load into HDFS and then um, uh, process the data using Spark, either Python or Scala or both. So we already have the data, so I am not showing how to copy the data and all, because it's already covered as part of the scope demonstration. So run here. So there are directories for department table. There is a directory for order items table, and there is a directory for orders table and order items tables as well. So we already have the data here. If you want to look at the sample of the data, you can just run Hadoop fs minus tail. Tail is similar to the Linux command, and it will just give you a preview of the data, fetching last few records from the file in the directory. So you have to give the path, including the file names, scoop import / order items / part star, and hit enter. So you cannot give the patterns like this as you can give in cat. So you have to give the name itself. To get the names, first letters do ls command. So there is only one file, which is part minus m minus 0000 cat, hit enter. I should have done tail. Okay, let me do the tail. Okay, now you can see sample of the data, and you can see it is comma delimited because we use typical delimiters. This is order item ID. The first string before the first comma is order item ID. This is order ID. This is order item product ID. This is quantity. So there is only one item in that. Means, for example, if you are trying to buy biscuit packets, so there is only one biscuit packet in this order, and then this is the subtotal of that order item, and this is the price of the product. Okay, so here if you see the order ID 68869 have 3 orders, and there and these are the subtotal of each of the order item. And if you want to compute the complete total of this order with order 68869, you have to add all these three things. Okay, so this is how order items is. It has order item, order ID, order item ID, which is primary key of this table, order item order ID, which is the foreign key or child key for orders, this is order ID, and this is a product ID, this is quantity, subtotal, and price. Similarly, if you look at orders and hit enter, you can see the 4 columns. First one is order ID, which is primary key for this table. This is the order date, and this is I think this is customer ID. So and then this is the order status. So this is the data set. We have order level details in orders and each item level detail in order items. And now let us define the problem statement based upon the understanding of this data. We want to get the revenue and number of orders on daily basis. So if you want to compute the revenue, we need order item subtotal, which is in order item table. There is that order item subtotal, which is in order item table, and also we need the date because we want to get this total revenue and also number of orders on daily basis. Hence we need the order date, which is in orders table, and also we need the order ID because we want to see the number of orders per day. You can get it either from orders table or order items table. Order items have order item order ID, which is nothing but child for orders order ID. Using this, you can actually get the number of orders for a given day. And so this is the requirement: get the revenue and number of orders on daily basis. And if you have to get this, we have to join the data sets, orders and order items. So now let's start launching the Pyspark. So we have to use Spark 1.2.1 because that is what there in syllabus, and that is what they will give as part of the certification. They will give a Cloudera cluster which have Spark 1.2.0 in them. And there is no difference between 1.2.0 and 1.2.1 with respect to syntax and semantics. It's a minor upgrade, so we can use 1.2.1, and also they will be providing you 1.2.1 documentation. And then you can say bin and Pyspark and use master local. You can use yarn also, but yarn is taking more time to be launched on the VM, so that's why I'm launching in local, and hit enter, and then it will launch the Pyspark. Before running the scripts on your VM, make sure it is launching with Spark 1.2.1 to avoid any incompatibilities because of the version mismatch with Spark 1.3.0, which comes out of the box of VM, and 1.2.1, which we have set up. That being said, first we have to read the orders data and then order items data. Then we have to join these two data sets. Before joining, we also have to split or parse the data and fetch the required fields from the data. From orders, we need order ID and order date. Those two are the things we need. From order items table, we need order item order item order ID, and then we also require the subtotal. So we need two fields from orders table and two fields from order items table. Once we get order ID in orders and order ID in order items table, we can join those two based upon the common column. If the columns are not common, then the join will not work properly. So before joining, you need to make sure that you accurately identify on which field you are trying to join, and also get the data without any issues. So to read the data for orders RDD equal to sc.text file, and it's under /user /cloudera /scoop import /orders. Okay, and hit enter. Before proceeding further, make a habit of validating until you get very comfortable with the syntax. You should be validating after each and every step you execute. So in this case, I am trying to validate for I in orders RDD dot take 5. So take is to get only 5 records from the entire dataset. Instead of fetching everything, it's better to fetch only 5 or 10 records. And colon, which is as per the syntax, and then you have to say print in braces I, whatever is the variable you are using as part of the loop, and then hit enter. so you are getting the data properly. You have the order ID, order date, and then third column is order customer ID, and then an order status. Similarly, we will be creating the variable for order items also. Paste. I am not validating it, but I will recommend you to do that. And now we have to pass this data. And if you look at orders table or orders data set, we need two fields. One is order ID, and the other one is order status. Sorry, order date. So this is the order ID is the first field in this data set, and order date is the second field in the data set. So we have to split each and every line with the comma as delimiter, and then we have to fetch order ID and order date from that. So I am running orders. I am creating orders map RDD. From orders RDD, I have to invoke map function, which I have explained earlier. Lambda. We are using lambda functions, and here you can give any variable O. I'm giving O here. You can give anything, and then I want two fields, O dot split by comma, and we have to get the first field which is represented by 0 in the array, and then we also need split 1, second field which is represented by 1 in the array, and then hit enter. Yeah, I have to put it in the braces. And when it comes to Python version, I think the VM have, because there are some syntax differences between Python versions also, and the VM is using Python 2.6.6, and let's see what version they are providing as part of the exam. Yeah, they are giving Python 2.6, so it should be fine. Okay, so now so you have to give braces here, as we are getting the tuples. These are called tuples. As we are getting the tuples, we have to put it in the braces here, and then you can actually validate again for I in orders map RDD take 5 print I, and hit enter. You can see that it has two fields. One is order ID, second one is order date. Order ID is of type integer, but here you can see that it is represented as string. If you want to typecast for any reason, you can do it by just applying int on order ID like this, and then you can actually print the data. And now you can see that it is not enclosing with the U. U stands for Unicode. Strings will be typically represented like this. Integers or floats will not be having this U before them. And then when we actually run the previous command, and when we actually apply the flat map, you have seen the square brackets. Square bracket means array of the items, and here you are seeing the circular brackets. Circular bracket means it's a tuple, individual tuple. Tuple is nothing but a key value pair. In this case, typically this will be the key and this will be the value. When we apply the flat map after flat map as part of the word count example, and if you observe, there also you see the circular brackets, and each the tuple there is each word comma 1, and here it's order ID and order date. That being said, now let us see the order items also. So let me typecast here, because I cannot typecast in one and I cannot ignore in other. And also, as part of the example, I am fetching only order ID and order date. If you want to fetch the entire record, you can actually pass the record itself. Now if I run this command and if I run for in orders passed RDD, the difference between the previous map and split and this map and split is that the second field is not the order date itself, it's the entire record. Okay, and then if you do collect take 5 and then print I and hit enter, you can see the first one has the order ID and the second is the record itself. So you can actually fetch the entire record also if you want. So let's follow this. Instead of fetching the individual items, we will try to fetch everything and then we will try to join the data set. But as I have typecasted at one place for the key, here I am typecasting on the second one also. And if you recollect about order items in the Hive, you can see that the second field is order item order ID and I want to get the entire record. So here by applying the split I am fetching order item order ID as key from order items dataset and the record as the value. So I am running this one. Paste it and again you can actually validate. Copy, paste, take 5, print of I. You can see the data. The first one is the key, which is order ID, and the second one is the value, which is the record from the order items table. Okay, now we have both the data sets. Now comes joining. So joining, it's pretty straightforward. Let me recollect the name: orders join order items, order join order items, and then you can actually do the join either way. I'm not focusing on performance here. I'm directly applying. If you are dealing with larger data sets in your real time, you have to focus on how you have to join. Typically, it is recommended to have smaller table here and larger table here. Yeah, it is recommended to join the smaller table onto the larger table. So you have to have the larger table here and the smaller table here, and orders is the smaller table because there can be many orders for each order. So order items is larger than orders table. So it is recommended to actually join the smaller table onto the larger table. So here you should have the larger table dot join and then the smaller table. There are many other things also which you need to actually consider while implementing in your project, but for certification I don't think that is very important. But do remember that you should always have the larger table and then join the smaller table onto it. Okay, so let me run this. Paste, and now the data set is joined. Again, I will recommend you to validate so that you understand how the data is represented in as part of the output. For in, copy, paste, dot take 5, print of I, and hit enter. If you see, join is a little bit expensive operation and it took some time, and you can see that now this each record have the key, which is order ID, and then have the tuple of for each of the and a tuple as and a value which is represented as a tuple, and the tuple have two components which are strings for first string being from orders table, and the second string being first string being order items from order items table, and the second string being from the orders table, because we are joining orders onto the order items. We have put orders in the brackets and order items outside. So the first string is order items and the second string is orders. It is very important to understand, because again, to fetch uh, order item subtotal and order date from order items and orders respectively, you have to pass these strings from this tuple. You have to fetch both the strings from the tuple, and then you have to pass it, and you have to fetch order item subtotal and order date. Okay, so when you try to read this as part of this is one tuple which have another tuple, and then it has key and values. So it's a two-dimensional array kind of stuff. So if you say t of 0, you will get the key. If you say t of 1, you will get this entire stuff. From this, if you want to get the first string, then you have to represent it as t dot t of 1 of 0. So within this second dimension, the first one is 0 and the second one is 1. So t of 0 means 32770, which is the key, which is simple numeric value, and then t of 1 means this entire tuple. T of 1 of 0 is this first string. T of 1 of 1 is this second string. So you have to do a split on t of 1 of 0 by comma and get the fourth value to get the order item subtotal, and then t of 1 of 1, which is this string, and you have to get you have to apply the split and get the second attribute to get the order date. So we have to apply a little bit complex split logic here. Let's do that. I am running. Let me recollect the variable name. It is join data equal to, the previous one is, let me fetch it from here, order, copy, paste, and then I have to apply map lambda t, because it is tuple, I am calling it as t. I have to get t of, I have to get the date first, because going forward my date should be the key using which I have to aggregate the data set. So I have to get the date first, and date is in t of 0 is this one, t of 1 is this one. In t of 1, 0 is this one and 1 is this one. So I have to get the second string, which is represented by t of 1 of 1, which is this one, and then I have to apply the split command by comma, and I have to get, after splitting, I have to get the order date, which is the second string in this, which is represented by 1 because the first one is 0. Okay, that one will give me the order date, and then I have to get the order item subtotal, which is here, which is t of 1 of 0 dot split, and split by comma. In this string, 0, first one is order item order ID, second one is order ID, third one is product ID, and fourth one is quantity, fifth one is the subtotal. So to get the fifth one, I have to say 4 here, which will give me the order item subtotal, and I want to cast it as float, so I have to invoke float function on this data set, and then close the map and hit enter. I think I have to give one more closing bracket. Yeah, so the first one is for the float, second one is for the map, sorry, for the tuple, and the third one is for the map. So I have to give 3 brackets and hit enter. Now it is working. Now we have to validate for I in join data dot collect, sorry, dot take 5 print of I and hit enter. You can see that you are getting the order date and the what is this field, order date and order item subtotal for that day for each of the order. So there are 3 orders for 2014 February 12th. So we are getting the subtotal for each of the order, and by if we add them, we get the total for the day. So that's how you can join and fetch the result. This order date is from orders table, and order item subtotal is from order items table. Now using this data set, we have to get the total of the order items and also the total of the order subtotal for a given day, and also we need to get the number of orders for each and every day. And we will see that as part of the next video. As of this video, we only covered how to join orders and order items and get the order date from orders table and the order item subtotal for each of the orders in the order items table. And our problem statement is to get both the revenue for each day and the number of orders on daily basis. So we will see how we can do that. That being said, I hope you are enjoying the content on my channel. If you like this video, please click on the like button. If you have any feedback, please use the comment section of the video. If you have any technical questions on this, please use Stack Overflow, tagging it with Spark and Pyspark. I will be closely monitoring and I will be responding to your questions. On top of that, if you want to discuss on any of the certifications, please do join my ITversity Hadoop certifications group in LinkedIn, and also ITversity Apache Spark if you want to discuss on Spark stuff. And finally, if you have not subscribed to my channel yet, please do so. You will get to see a lot more content like this over time. That being said, thank you. Bye.